Okay, look at partial derivatives of contour maps. This time we're going to look at the partial of f with respect to y, or looking at the change in our function values as we go in the y direction given a contour map. All right, so we have the same curve as the last one, x squared e to the negative y. We take the partial with respect to y, keeping x constant, so just take that negative and throw it in front. I picked a point over in the, it looks like that's also in the fourth quadrant. And it looks like the partial is negative as we go in the y direction, negative 2.99. So here is our curve. And the point we're talking about is here, point D. So notice that my function value at D is 3, and then it goes down to 2.5, and then to 2, and then 1.5. So clearly it looks like my function values are decreasing, so therefore Fy is negative. Let's look at the average rate of change between D and E. Average rate of change goes from, my change in Z values is from 2.5 to 3. And my E, I'm keeping X constant. So I'm just going to subtract these two Y values here. And I get negative 2.7824. So it looks like our partial with respect to Y is negative. Just using the average rate of change in between two points on the contour map. And then I did the same thing, and I took the points and plotted them on the XY plane. But in this case, my x-axis is y, and my vertical axis is the z. So there are my function values, 3, 2.5, 2, and 1.5. Those are coming from the contour lines there. And then my x values in these points here are actually my y values from my curve. And clearly it looks like as I go from left to right, or as I increase my y, because my x-axis is my y-axis, my curve is going down, so therefore Fy is negative. One more, so F is decreasing, sorry, and Fy is negative. One more quick example. I came up with this curve, x sine y. Here are the contour maps over in the fourth quadrant. And as you can see, I'm looking at this point right here. It's kind of a different one. Even though we are going down, but at this point right here, notice that it's a point of tangency to the contour line. So therefore, it actually is the derivative at that point would be equal to 0. So you can, here's the math. I plugged in negative 2 comma negative pi over 2, and then I got 0, which is kind of cool. If you think about it, it kind of makes sense because this right here is a ridge. Why? Because here's 1.5 here, and then I come back around, this purple line would intersect 1.5 again. So you're just kind of coming up and over this ridge line right here. And I also graphed it on GeoGebra in a 3D grapher. We're talking about this point right around here that we're coming up and going down. So therefore, this point right here, the partial with respect to y is going to be 0 because my green axis is the y-axis, which I thought was kind of cool. That was a different example.